Hello, I'm Bob Gazda, and we're here at the Mobile World Congress with InterDigital. We have a panel today where we're going to be talking about how far edge computing can take us into a new network architecture. We have a panel of some industry experts here, and we're going to be discussing edge computing and virtualization. The fever and the excitement on edge computing and virtualization does not seem to be abating, almost accelerating. And there's also interest about taking compute resources further and deeper into the network, into customer premise equipment, even onto mobile devices such as robots, drones, and automobiles. But when we bring edge computing to that extreme edge of the network, where we experience many challenges. They can be technical, they can be regulatory, they can be business challenges, and how can we succeed? How can we address these challenges? And that's what we're going to be discussing today. So I'm just going to take a minute to introduce our panelists, and then I'd like each of you to maybe expand on yourself and your interest in edge computing. So first we have Rolf Schuster. He's the director of the Open Edge Computing Initiative. We have Laurent Depersin. He's a director at Research and Innovation Home at Technicolor. We have Arturo Azcorra, and he's the director of IMDEA and VP and co-founder of Fivetonic. We have Todd Spraggins, and he is the senior director of communications business, global business at Oracle. And last but certainly not least, we have Dirk Trossen. He's a senior principal engineer at InterDigital, and he's also the technical manager for the Flame project. So, Rolf, please.
Thanks, Bob. So, thanks for the introduction. So, my name is Rolf Schuster. I'm, as Bob said, the director of the Open Edge Computing Initiative. As such, maybe just to say one sentence about that, this is an interesting consortia with a target to really make edge computing a success on the business side as well as the technical side. And hence we tackle key challenges, which I will talk about more later on. And basically I lead this initiative with members like Deutsche Telekom, Verizon, IMDEA, Vodafone, and they are all very interested in making the edge a success. So I can report directly about what they are doing and what their intentions are and what the hurdles are right now. In real life, I also have a professorship at the German University, also focusing on edge computing from a research perspective.
Okay. So on the side, leading the research and innovation home experience lab at Technicolor. So the home lab is around 30 people, 30 researchers, mostly working on edge computing, but not only, we're working also on AI related subjects, media streaming, and of course also some other topics, some corollary topics such as IoT platform, things like that.
So my name is Arturo. I am Vice President of Atomic Laboratory and I'm also Director of IMDEA Networks. So I find really exciting this new era that edge is going to bring, especially extreme edge. I think it's a big milestone in telecommunications, and I think that it's definitely going to take us to a new architecture. Actually, I think that this is the beginning of a new architecture. Networks are going to be totally different with the introduction of computation inside them. They are not anymore an end-to-end device.
Hi again, Todd Spraggins with Oracle. I manage strategy across our portfolio and the communications products. And our primary interest is with Edge is really to treat it like cloud. And we've been working hard on bringing cloud native concepts into the broader market, especially into the carrier space where NFV hasn't necessarily been all that successful, and that really going cloud native is more than containerization. And so just because you're taking something, put it in a container, and you put it on a box in the edge doesn't necessarily mean that it's going to be a contributing factor to the cloud, and that there takes other aspects and backing services and orchestration and other aspects to really make that edge part of cloud so that you can say that edge is cloud.
My name is Dirk Trossen. I'm with the InterDigital Europe office, and I'm leading the network systems team in the office. We started with edge computing around 2016, when we had the first proof of concept in Mobile Edge Computing, and we had a first trial in 2017 where we tried edge computing concepts in live deployments in Bristol at that time. We turned towards service-based architecture in 3GPP to really drive the evolution forward from the ETSI-MEC type of view of the world towards a more cloud-native view that goes from a distant cloud to at the edge, and as we demonstrate here, down to the terminal.
Okay. Thank you, everyone. So I'd like to start off the discussion here of maybe taking it up to the highest level. Let's just talk about the importance of edge computing. I'd just like to hear your thoughts on what are the drivers of edge computing. Maybe if I ask that same question slightly differently, what applications do we think are really require the edge? Without the edge, they just can't be realized. Laurent, can you share your thoughts on this?
So of course, I mean, the edge computing is bringing a lot of attention and a lot of benefits when you want to have applications with requiring low latency, and you can also benefit from location aware or applications that are also needing data transfer to and from. So it's of course where you will find the most interest. I think if you are looking especially about the applications that are on the verge to really become mainstream, cloud computing, cloud gaming are really the one that is getting mainstream right now. And when you look at the news, all the GAFAM, they're now promoting a lot these technologies, and you can find, I mean, here and there, a lot of initiatives related to edge computing. Another application where we see a lot of interest is also AI that you can have at the home because of the privacy issues, and also to benefit from the CPU and local storage that you can have with CPE boxes that you have at home. It's also a really interesting thing to look at when you're considering edge computing plus far edge computing with CPE boxes.
Okay. Does anybody else have any thoughts you want to share?
Yeah, maybe just to add to that, I guess apart from the key driver, Laurent has mentioned where we look for low latency on one side and for big data and large volumes of data on the other side. I think there is an interesting development right now where we distinguish between so-called edge-native applications and, how to say, edge-supported cloud applications. And the difference basically is that you can take existing cloud applications that run in the cloud happily, can bring them to the edge to improve the performance, like latency, like customer experience. So that's edge-supported, edge-enhanced cloud application. And then we distinguish from that the edge-native applications, like you said, applications that actually need the edge. It wouldn't work otherwise. For example, a head-mounted display that actually needs a low latency, otherwise you cannot put it in the cloud. So this is edge-native, and we see lots of things coming up in that space. There is something called 360-degree video, where you kind of stream a 360 video to the edge, and at the edge you select the part of the 360-degree video the guy is looking at with the handset. So if I move the handset, a different part of the stream is sent to the handset. We also see applications around automotive emerging, around drones, and so these areas will also require edge-native applications to run at the edge.
What are your thoughts on where the edge of the network should be? Maybe if we talk about this extreme edge where we're getting closer to devices. Any thoughts on that border between the network and the device, where that starts to end and blur? Arturo, do you have any thoughts on this?
So I think, unfortunately, you will need several borders. So it would be very good to have only one and to define something perfectly standardized and that it serves all possible situations. But I think that the experience that we have been gathering in Factoric in collaboration with InterDigital and other leading companies shows that we are going to have several borders. Because in the end, depending very much on the application, and we already have listened to my previous people in the panel describe two very different cases. the proper, correct order to use going to be different. So I think we will have definitely something very, very close to the use, like extreme edge, like running even in the old user device. You'll have something slightly farther away, like so to say on the base station, and then you will have like more powerful distributed computer centers, and of course in the end you will still have the cloud. So the cloud will be there, totally end-to-end. This will stay. So we will have a range of different intensity edge devices. And I think that's going to be absolutely beautiful because it will allow us huge flexibility to address many, many different types of applications.
We talk about technologies, so let's maybe move into technologies and technologies that are needed to enable the edge. We're observing this proliferation of microservices down to the extreme edge like we've been talking about. You see activities happening in standards bodies. One example is the service-based architecture, the enhanced service-based architecture within the 3GPP. Where do you see this service-based architecture taking us in this space? Dirk, can you share with us?
Service-based architecture so far has really only just started. In release 16 at the moment, as SBA is purely focused on the control plane, and a lot of this is probably down to political reasons more than technology reasons. But we already showcase now that SBA principles can be applied across the entire spectrum, and they should be applied across the entire spectrum because that's where the real benefits lies. If you want to push services very, very close to the end user dynamically, you can't stop at the mobile core network. You have to include the radio access network. You have to include, as we mentioned before, the actual devices themselves. You have to include devices that come from neutral host providers in your immediate vicinity. We work with neutral host providers in our trial in 2017, for instance, in smart cities, where the actual concept of a core network is significantly different because we're talking there only about a metro data center and micro data centers in street furniture, right? And that's a very different scenario. It has to include all of them. And SBA as a design principle and as a set of protocols applies really across all of them. And only that's when you reap the benefits of increased efficiency, reduced latency, increased flexibility of providing services.
Okay.
Right. I believe that when you look at what SBA really means, you've got to put some more emphasis on the service aspect. I think typically the telco industry has placed too much emphasis on functionality that drives you to this point-to-point type of interface architecture. And really what's been refreshing with SBA, at least with release 15, was the notion that, okay, I'm going to have a service, it's going to be API defined, and then that will let people use innovation to either create new services or to consume those services and to put the end-to-end picture together. I think as you go to the edge, you've got to start thinking about, well, what makes that different? And how can I take what's being done in the control plane and actually start putting it down into the user plane and potentially even taking the control plane down into the network itself. I think too many people think control plane stays at the top, and it doesn't necessarily have to. Where we've been emphasizing our efforts has been around the enhanced SBA and release 16, and one of the issues you have is around service discovery and making certain that you have reliable service communication. Because I know we're overall providing a communication service, but if the components, the microservices can't communicate, then you're not going to be able to pull it all together. I think that becomes even more critical when we go down to the edge. And so what does it really mean to do like a service mesh and to have location-aware service discovery down in the edge? These are issues that definitely weren't addressed in the release 16, and hopefully we can get to them in 17 and beyond.
Following up on that, at that extreme edge, near edge, far edge, however you'd like to call it, you start seeing more volatility in devices. They may be mobile. They may not be always available. They certainly won't be heterogeneous in terms of capabilities. So there's a lot of volatility and all kinds of issues that go around with managing, orchestrating, using those types of far edge or extreme edge platforms. Do you think you can do this today? Do we have the technologies available? Arturo, do you have any thoughts on this?
No, we do not have the technologies available, but we do have most of the pieces. So the control of the devices themselves, actually it's an application very suitable for Edge itself. Like if we take what are the requirements for an application to be suitable for Edge, we said low delay, big volume of data, and also sometimes the metadata. And this is what we have here. You need very low delay because you need to react to devices that are very volatile. You need to handle a substantial amount, large of data, because collectively all these devices will handle a lot of processing data. And also you need to access the local metadata in the base station, for example, the direction of the devices, what's the path record, what is their context, what is their radio coverage. So to me, this is very, very suitable to have such a controller running precisely in the edge. We do not have the solution today, but we are coming very, very close. And I think in at most 1 to 2 years, we will be able to see this demonstrated here at Mobile World Conference.
Okay. Does anybody else have any thoughts on this topic?
So we are speaking about the devices, the CPE or the mobile phones. I mean, the ecosystem, they fragmented a lot. So it's also a good benefit. For instance, if you want to support mobile phones, you can support only Android and iOS, and that's it. You are covering. You have already a good coverage. All of this is making easier to envision. Integrating this type of new devices into the loop to have really a closed loop system.
Yeah, just to maybe also add to that, I guess I would agree the technology is not quite there. Nevertheless, we can already do edge computing today, right? It's not that we would have to wait. I mean, we can take a lot of the cloud technology, install it at the edge and run with it. Where the limits are is basically when we really have 10,000s of devices all of a sudden that are distributed, and we try to efficiently manage those with zero-touch management concepts, right? Which is important. Otherwise, the thing becomes too expensive. So there, the limit really starts today, and but we shouldn't leave the impression that we now cannot do edge computing today. I mean, the message is we can do it with, whatever 10, 20, 100 nodes in a country, but beyond we will have to do things, right? We will have to change. We need new technology to work.
Okay. Any thoughts on third-party edge service providers? So an edge provider that's not a telco, right? So it's not the telco edge. It's provided by maybe a tower company, maybe an enterprise, maybe a venue. Any thoughts on that, Dirk?
Yeah, so in 2017 when we ran the trials, we very much focused on what's called the neutral host model. And these are, in particular, smart cities. They are venue providers. We talk to building management companies that work in that space. Essentially, establishing rack space with layer 2 connectivity, right? And that's from the cloud native perspective, the basis of essentially placing a cloud native platform on top. And a lot of these scenarios, and going back again, what are the benefits? Low latency has a lot to do with localization of the use cases. Think about a theme park. An AR, VR theme park is all about localized experiences in a high computing environment, and all of this really done on a vanilla, cloud micro cloud center that you can actually buy from these type of companies. The neutral host model really pushes you into thinking of opening this up to application developers. One of the pieces that we showcase in our demo here is to marry application development and application installation with service orchestration. So it allows us to make the deployment of a service part of the application installation, where it's not only a model that goes from an application on your smartphone to a distant cloud data center, but it actually, as part of the design process, includes the deployment of a service in a nearby infrastructure, right, which can assist you in certain functionality. And that has to happen obviously as well. So there are these two parts of the facility and platform provider, and obviously the application part as well, the application development.
Okay, right, okay.
I'd like to add that I think to flip that back around a little bit, that the telcos are going to have to think about this from the perspective of the others. And what I mean by that is today there's this expectation that if I build Edge, I'm going to have my own version of orchestration. I'm going to have developers create VNFs. That may work for a security application where the industry actually, or that company understands the telco industry, but that's not going to work for all these other applications that are going to want to go to the edge. If this doesn't look like, what Amazon, Oracle, AWS has, then you're going to find that you're not going to have that critical mass of developers coming and knocking at your door. So it's just absolutely essential that Edge really isn't differentiated to some extent from the cloud that these developers are used to, even though we do know that there will be certain things we have to add to make Edge real.
Okay. And maybe just to add from my side, I think it is very important that we don't consider edge computing as a thing that telcos do. I mean, this is much wider than that, right? This could be cities, this could be utility companies. This, of course, is today already the hyperscalers, the cloud providers, because they go closer to the edge. They get more and more data centers out on the planet, and they want to also be close to the customer and to the user. So I think it's very important to be open, to allow anybody who would like to play in the edge space to play. However, it's very important that whoever plays, telco, city, hyperscaler, that they agree on some concepts how to use it, right? Not at the end of the day that we have a city type edge, we have a telco type edge, and we have a hyperscaler type edge, and at the end of the day, the application developer is confronted with a patchwork of standards and concepts, and he cannot develop with one concept.
I totally agree on what you were saying. We don't have to close this edge computing topic to the CSP, to the telcos, and I see huge opportunities also for verticals, transportation, energy, facility management. This a bit the same way that we've seen in the past with MVNO, or that they were selling virtual network operation to others. I mean, it was a resource that they were selling. They were not owning at all the network, but they were selling the asset, the resources. I think we will see the same things happening. Or we see this happening with 5G and RU, where finally it's no longer the carrier that are owning the spectrum, and you see many energy companies that are interested by having their own NRU network. So this is really a mix of that, yeah. And maybe we will probably see happening new actors joining the market and trying to sell this new resource.
Do you see that even extending into consumers' homes?
Definitely. I mean, definitely. This is probably the next challenge will be to propose to have really this resource at the home used by the telcos. Of course, the original proposal that was done for the edge computing was more limited the edge up to the RAM, but it's also because there was this fragmented environment for the in-home CPs. And we've started, I mean, at Technicolor especially, we are pioneering to defragment this world and use open source. We are using, for instance, Homeware, OpenWRT-based OS inside our gateways. And we are opening this to third parties so that they can develop their own applications. We have a Euro partner program for that that is really open way to share the benefits of having on one hand good customers that we own at Technicolor, because we have good relationship with big telcos and big CSPs, and of course for smaller companies to be able to access those big companies to sell their new applications.
I definitely also see a clear role for other entities besides the telco. For the extreme edge or fog, whatever you want to call it, clearly because the extreme edge devices are not in principle controlled by the telco. It's the home device of the user, or it's a car or a drone controlled by Amazon or whoever, or it's a mobile phone. And all these devices are not under direct control of the telco. So in this case, I clearly see a big role for other institutions, other companies doing this. But even for the, so to say, conventional edge, when the computers are inside the network, and the telcos are already used to this, with the local loop unbundling, they had to accept for regulation to put in their cabinets equipment from competitors. And they don't find it so horrible now. And I think we could have hosting of equipment like they did also with Akamai. So Akamai was placing their systems inside the network to achieve better performance. So I think this will come for sure. It will not be maybe so easy to find out what's the proper balance, but on my view, it will come for sure.
Okay. I'm going to switch gears slightly. Let's talk about standardization, industry consortia, and open source as a big category. So we definitely see there's a range. There's many edge standards. Edge is being addressed in many bodies. There's also industry consortia. There's alliances. How can we make sense of this a bit? Which ones are relevant? Do we think we need more coordination, cooperation between the groups? Is it working? Is it not working? Rolf, can you start us on this?
Yeah, thanks for that question, Bob. I guess as an open edge computing initiative, the consortium I lead, I guess we have always been promoting the idea of creating one common mechanism to use the edge. However, then if you look around, by now there are, last count was 23 different consortia dealing with edge, and all of them claim we need one mechanism to use the edge, right? So this is a bit funny situation that so many organizations all want one common thing, but still they don't talk to each other, right? So what we have done actually was last year, we invited the main consortia to one workshop and said, guys, please come, we have to talk, we have to understand each other, I have to understand who contributes what to the overall ecosystem. And Court was there, OpenFOC was there, TIP was there, right? I mean, all the main edge consortia of today. And it was an interesting outcome. At the end of the day, we discovered that we all look at different portions of the universe, and there is not too much conflict yet, mind you, right? Not yet. So I still see a chance that we converge on an overall, at least a basic mechanism to utilize the edge, like you use Wi-Fi today, right? So I envision that you have a basic functionality. There are different kinds of, some are paid, some are not paid, some are in a Starbucks coffee shop, whatever. But this common base, I think we still have a chance to come to, and I should also mention ETSIMEC, right? This standard that the telecom industry itself has come up with. So all of that has to come together at the end of the day in order to be attractive for the application developer, right? If we don't manage that kind of convergence, then the application developer will sit there and will say, well, what should I do? I have 23 different mechanisms here. I'm not going to do anything here, right? So we have to convince them that there is one mechanism and that it's an attractive business to invest and to develop application for.
Okay.
The business model that you can have with this is very important. I totally agree with you on that. I mean, the success, for instance, if we look on the mobile, the success of the App Store, it has been because it was a single. I mean, it was really clear. For the developers, it was clear that if they were adopting this development, this platform for doing their applications, they could get the revenue. If we continue to have, so many standards, no way we can have this happening. So I think the Linux Foundation's recent initiative to try to clarify the situation is quite good. So let's see if they succeed in doing this.
I was just going to add that it's important for these industry fora to exist because they really collect the requirements around edge, because I don't think the folks that are necessarily working on traditional core network and core cloud issues always understand what's really required there. But I think there needs to be some a little bit more cooperation with folks that you may not normally think of. When you go look at how Edge is going to get built, especially if it's going to use a microservices, service-based architecture, you're going to draw from existing cloud technologies like you find in the cloud-native compute foundations ecosystem, and you're not seeing those guys brought to the table. And I really think that, for instance, if you're going to want to schedule microservices using the container technologies out there, then you need to be talking to the container scheduler guys. And the same thing with the service mesh. If you want service mesh to incorporate concepts necessary to actually work in a highly distributed environment, you need to go talk to the service mesh guys. Otherwise, you're just going to end up with a set of requirements, some interesting APIs, and it's going to be disjoint from the technology that these developers are using.
I have a follow-on question on this one. Do you think there's too many silos in that, where there's some solutions in some space that could apply into other parts of the Edge ecosystem, but they're just not connecting the dots at the current point?
I believe there is, but I don't want to put a negative cast on those silos. Those silos are extremely important because they really tease out what's important for those particular ecosystems. Like we're already seeing a couple of automotive, 5G, AA type of activities. Those are important because that is an extremely complex problem. And I don't think a broader industry body is going to really be able to tease that out. So they absolutely have a purpose. It's just as a community, we need to cooperate a little bit more and not be afraid of saying, okay, I'll turn this over to you, but please understand my requirements.
So your last comment there, I think, is a little good lead into open source and sharing. Any thoughts on open source in the Edge ecosystem? Arturo?
You see a room for open source. A few years ago, people would think that making any commercial product in large-scale production open source would be crazy, would be impossible. But I think now we see that open source is gaining substantial credibility, I would say, from the actual, both the final consumer or the final company customer and the intermediate provider. So I think there is a clear role for open source. We will need to wait until the system stabilizes a little to see in what parts of the system will see open source. But on my view, there will certainly be a substantial amount of open source, and everything will not be 100% commercial proprietary systems.
The problem with with proprietary system is that, of course, that you cannot exchange easily with others. This is one problem, but it means that you have also this lock-in to one system, and of course this prevents from the technology to get rapidly adopted. So I don't see it happening except if it is open source. Okay. And we've seen it, for instance, with ONAP on the cloud. The time ONAP gets defined. You had to see several initiatives, but it did not get up to the level that now we see with ONAP for the VNF or open source model or this kind of standards, which are really getting adopted by the CSPs. So it's a bit the same way.
I mean, for me, open source hopefully plays a vital role here. I guess if I just look at the current situation, there are at least 5 to 6 different edge platforms out in the market today, right? So edge platform means these are the guys that receive a request from an application to provide an edge at the location XY, and they populate that edge node and provide the service. So these guys, 5 to 6 platforms are out in the market, and I ask myself now, they all have different APIs. They just develop their thing and they hope to be successful in the market. So my vision is at the end of the day that hopefully they all get together and realize that yes, they have to differentiate. I mean, they are competitors, but there is a basic set of functionalities where it should be easy for a developer to use that infrastructure, to build it into his code, that they have to at least agree on that part of the mechanism to use the edge, and that ideally, that they open source that code jointly and make it one set of APIs, if you want. And open source is a good mechanism, and I'm not talking about open source publishing your code, but I mean open source in a community that that is governed, that has rules of engagement, that actually further develops that over time. And then everybody who has a good idea, who has is competent, can contribute to that. Right? So I hope this works, and we have seen Arturo, for example, already being out in the open source. We see Airship out there, all edge-related open source stuff. And I hope that we also can bring this API section, Edge application developer APIs, that we can also open source that.
Okay. I'm going to shift gears a little bit towards commercialization, but I want to ask a leading question around standardization. And I know this is asked before, but you still get many different answers, so I will ask it anyway. Is 5G required for edge computing? Do we need release 15? Do we need release 16? Can we do things on release or on 4G now? Todd, can you expand on this?
The answer to that is a big caveat, yes and no. And so I think when you go take a look at something like, you say microservices is SOA that works. I like to say slicing is dedicated core that works. So realistically, when you move that forward and you look at, well, what does edge really need in a mobile context? I would say it's, let's take this overlay session-oriented view of the world and move it to one where mobility really works, and that you have something a little bit more sophisticated, something that actually involves the end application and determining how paths are selected instead of the sort of semi-clunky way that you have handover occurring. I think that's going to be a real boon to the edge. You can do a lot in edge today with LTE. Okay, there's bumping the wire S1 to sort of taking the S gateway and dumping it off a local offload. Those things exist. It's actually helping. It's showing people that there's business value in having the edge. But the problem is it's not the most effective way to do the edge. It's not cost effective for the carriers, and it's definitely not the preferred method for those who are going to build the edge applications. So I think really we're now beyond 16. So 16, the SA2 just is wrapping up. Really, we need to start looking at 17 and what can we do to really make edge a first-class citizen, especially around the mobility aspects. So it's all of the above.
Okay. Monetization. How do we see edge monetization working? Laurent, do you have any thoughts on this?
So I already mentioned, I think some new actors will, there is a huge opportunity to create new virtual operators for edge computing, for edge resources. It's, because you can intermediate this new resource to end users or to developers. We can imagine kind of app stores, kind of stores for this edge application. And of course, this could interest also some verticals and other, probably actors that we don't see right now in the loop, that we probably want to join and then bring their whole expertise. IoT, smart security, or a lot of things, transportation, I don't know.
The pad around neutral host providers that we focus on actually really moves the emphasis from cellular providers a lot to what we call site-specific deployments, right? And that brings industrial IoT to the stage. Remember, an edge could be an entire nationwide cellular network, right? And with what's currently going on in release 16, you establish a distributed cellular 5G LAN. It makes every scenario in a cellular network essentially a corporate intranet scenario. all right, and with a potentially, the actual base services being provided in the corporate headquarter, and your entire distributed service being run over a cellular LAN in an entire nation coverage, right? It makes it extremely powerful, and it moves it really, I think, away from an MNO into the MVNOs, which are essentially application service providers. And that, I think, is the dilemma really for mobile operators to make a very good decision of where to place edge infrastructure, because I think a lot of it is really driven by the business idea of a mobile operator. I have to own the services. I don't. A mobile operator has a huge advantage, and that is facility. And if I have facility, I can provide compute infrastructure in a neutral host model, which is a model that's fairly alien to a lot of operators. I think that's a little bit the problem. But these new providers, as I said, like smart cities, industrial IoT, will shake up the business quite a bit.
Okay.
Of course, I mean, it will be easier for the existing actors when you are having already OSS, BSS that are part of the CSPs, it's easier for them to collect the money. So probably they could be the one to derive some new use cases and probably to grasp some opportunities at first. Maybe
relating to this, I mean, I got a fairly snappy answer or question back from a major European operator who said, well, if you can tell me which of my 15,000 base stations I shall place a micro data center we own business, I can't. But the thing is, site-specific providers can, because they deploy already at the site where the value is going to be. So they answer the question already. I mean, if you go to a site provider or you go to a building management provider, they already have a micro data center in the basement. They don't have to answer the question because they already did. And all it really is, it's a micro data center with a little bit of L2 connectivity in-house, buy a cellular connectivity around as a VNF from a mobile operator, and you're in business. It's the site provider who's in significant advantage over the operator who would have maybe answered the question but didn't even have the facility to deploy the micro data center there in the first place.
Maybe just to add to that, I think we have a fundamental chicken and egg problem here, at least looking from a telco perspective, because basically the telco has to invest relevant money to get the edge to work and get it set up and roll out 100 sites with GPU, with lots of hardware. So that's a relevant investment. On the other hand, there is the edge application developer who says, okay, do I invest in this, develop an ultra-low latency app or not? And both sides look at each other. The telco says, well, where are the apps? Where are the edge native apps I can make money with? And the edge application developer says, and where is the edge? Where can I deploy my application today? So the question is, this is a fundamental business problem of an enabler technology like edge, where an enabler supports many different types of applications, but he needs a minimum of these applications to work in order to make business sense. But the question is, how can we come up with a set of interesting and business-wise attractive applications that actually support the case for the operator as well as the edge application developer? And currently I see the opportunity coming from also the cloud side, where the cloud native applications realize that if you bring them to the edge, that the performance is better for the customer, and that this will be the first source of revenue we will see soon, right? Coming from the edge. And then step by step we have to, really show a cool applications on the edge that wouldn't work otherwise, so edge native applications, and step by step try to build this infrastructure at one hand and drive the applications on the other side.
Okay, so we're getting close to time here. So I would like to wrap things up by asking all of you a very broad general question. So if we look to the future, maybe we even call the future beyond 5G, where do you think edge computing is going to be in 5 years, in 5 years' time? Dirk, can you kick us off?
Well, I presented recently an edge story at the Network 2030 meeting, which is beyond 5G at the ITU, and it's always very interesting when you ask the question about the edge. The question was asked before. I'm a network system person, and for me, an edge without the terminal makes no sense. because the terminal is the communicating end device towards the network. But I had a very strong rebuttal from an operator sitting in the audience saying, well, that's weird because at the edge is the network, right? Which I don't really quite understand. I think, to me, the edge is really going to move outside. It is going to move from the core to the current edge we have in the RAN, and it's going to move into the terminal. It's inevitable because that's where the services lie. That's where the execution is happening. That's where the users are. And if the users are there, that's where the money is.
Okay, Todd?
I'm going to be optimistic and say I would hope to see we finally realize that this is actually a spectrum, and that in order for us to really move forward technology-wise, we've got to invest all the way to where the device does computational activities and is synchronized and as easily as deployed as the computational activities that occur in the actual central data center. And that from a developer's perspective, you know, the entire cloud is my ocean and I can deploy to all of them. I think right now we seem to put it into all these different silos and make the problem a lot more difficult from the perspective of the application provider. And it's when the app developer can really utilize that entire spectrum, then we'll have actually achieved edge.
Okay. Arturo, your turn.
Okay, so I have, I would say, a very, very long-term view of this. Since the telecommunications were invented was in 1850 with the telegraph. And since we started with the telegraph, sending telegrams, we've done it in almost every possible way. We've done it with packet switch, circuit switch, in analog mode, in digital mode, in unicast, multicast, anycast, broadcast. And we have been, along the last 170 years, moving information place to place in many different ways. And somehow I see mobile edge computing like starting. It's the first time where you have actual computing inside the network, and people don't want to talk across the network, they want to talk with the network. So you don't need to talk with anybody else. You just want to talk to the network. So maybe we will have 100 more years of edge computing in many different ways, in containers, in virtual machines, with operating systems, real-time, non-real-time, parallel, single-thread, because we may be having this invented and reinvented in many different useful ways. And this is how I see it, like the starting of a long-term road.
Laurent?
So for me, in fact, when we are looking at edge computing, we don't have to look at it as an isolated thing. I mean, it's a part of a global change that is happening in the network, in the CPEs. For instance, we observe the defragmentation of the stacks, softwareization at all levels, slicing, SDN. So it's a huge trend that is happening in all the chain. I mean, from the core network up to the CPs. And all of this will continue to happen, and then all of this will favor the edge computing. It will get easier and easier to have this edge computing happening. So when you mention whether it's linked or not to 5G, for me it's not directly linked, but in fact the trend that is happening right now with the cloud native technologies that we observe, with the softwareization, using more and more less and less proprietary stack and using more and more open source, it's also favoring. Those are enablers to edge computing. So I think 5G in this sense will probably pave the way for really edge computing being massively deployed in the beyond 5G.
Okay. Rolf?
Yeah, maybe sometimes if you try to predict the future, it's good if you look to the past and see what has happened. And when I look to the past, what do I see? I see that there is a pendulum swinging between back end and front end. It's always, there has been mainframe, there has been PC, there has been this, there has been that. And now there is cloud. The pendulum is on the cloud side in the back end, and it will swing back. And this is where edge is an incarnation of, right? So I am strongly believing that this is coming and it will stay. at least until the pendulum again maybe is going back, but in 5 years we will have a lot of edge computing, first of all. And how does it look like? I mean, today we look at edge computing in a way that, we have, instead of client server, we have client, edge, and server, right? However, so it's 3 tiers instead of 2 tiers. But I think this is a much too narrow view in 5 years. In 5 years, we will have containers and little pods everywhere running in an application, and we will distribute that across many nodes. It's not just 3 nodes, so the user equipment, the edge, and the back-end cloud. It will be n nodes, it will be n tiers. And we will need a technology that is able to orchestrate all that. Right? So this is how I see edge computing in 5 years. These applications are split up in small components, small elements, and it will be, how to say, liquid computing across all of these end nodes.
Okay, very good, very good. Well, I think we can wrap it up. I want to personally thank each of you. This has been an excellent discussion. I really appreciate it. I hope everyone enjoys themselves at MWC, and thank you very much.